So, Bismillah Rahman Rahim, Assalamu Alaikum. So, in this video, we will be discussing about the theoretical part of sieve analysis test. So, let's start the video. Firstly, we will be discussing about the background concept of the sieve analysis test. So, grain size analysis is the determination of particle size which make up of grain or given soil. So, sieve analysis is basically the grain size analysis. In this analysis, we determine the size of the particles of the soil. So, it's difficult to obtain individual grain sizes. So, test can only bracket ranges of the sizes. So, through test, we basically try to determine the size of the particles of the soil. So, there are some major categories of the soil grains, and first one is coarse grained soil and the second one is the fine grained soil. So, how we basically differentiate between coarse grained soil and the fine grained soil. So, the boundary between the coarse grained soil and the fine grained soil is sieve number 200. In few minutes, we will be discussing about what is basically the meaning of the sieve number 200 and sieve number 4 and etc. etc. So, for the time being, let's try to understand how we basically differentiate between coarse grained soil and fine grained soil. So, if the material passing from sieve number 200 is more than 50%, then the soil is termed as fine grained soil. And if the material passing from sieve number 200 is less than 50%, then the soil is termed as coarse grained soil. For example, if the material passing from sieve number 200 is 46% and the material retained on sieve number 200 is 56%, then it means the soil is coarse grained soil, because the material passing from sieve number 200 is less than 50%. So, this is the concept of coarse grain and fine grained soil. So, we can say that the sieve number 200 is basically the boundary between coarse grain and fine grained soil. So, let's try to understand this differentiation in more detail. You can see here the brief explanation of this classification. The material that is retained on sieve number 4 is termed as gravel. The material that is retained on sieve number 4 is termed as gravel. The material that is passing from sieve number 200 is termed as fine. So, fine is further categorized in two types, silt and clay. Then the material that is passing from sieve number 4 and is retained on sieve number 200 is termed as sand. So, size of sieve number 4 is 4.75 mm and sieve number 200 size is 0.075 mm. So, let's discuss that what is the meaning of this size 4.75 mm etc. So, before discussing this, there is some explanation regarding the classification, like gravel can be termed as fine and coarse depending upon the size. Like you can see here, if the size of coarse material is greater than 19 mm, then the gravel is coarse. Then here comes the size of cobbles. You can see the range between 300 mm and 75 mm. The size is termed as cobbles, and the size of particles greater than 300 mm is termed as boulders. Now, moving on towards the next, sieve analysis. So, it is basically a method which comprises of sieve sets, and you can see here the sieve set. It comprises of different sieves. So, we basically obtain from the sieve analysis the percentage of sand, gravel, and fine. So we can say that sieve analysis is basically used to classify coarse grained type of the soil. So it's basically a mechanical method, not the automatic one. So different sieves can be used in a sieve set to obtain particle gradation curve. So later on we will be briefly discussing about the particle gradation curve. So usually we can use sieve number 4, 10, 16, we can add 20 as well, and then 30, number 40, number 50, number 100, and 200. So one can add more than the sizes mentioned here. So what is sieve number? So sieve number represents the number of openings in one linear inch dimension. For example, sieve number 4 means that in one linear inch dimension there are 4 clear openings. So this is the meaning of sieve number. Now you can see here the smaller sieves are numbered according to the number of openings per inch. You can see here in one linear inch there are 4 openings. Now the size we discussed a few seconds ago, that sieve number 4 size is 4.75 mm. The point to notice here is that if as per the definition, if we convert the units, 1 inch is equals to 4 openings. So if we calculate the one opening size, then it will become 1/4 inches, and if we convert this value into millimeter, and it becomes approximately 6.2 mm, but the size we defined for sieve number 4 is 4.75 mm. So the reason is that in the sieves there is a mesh size. So mesh size, so we have to exclude that size. If we exclude this the size of the mesh, then the size of clear opening will be 4.75 mm for sieve number 4. So this is the reason. So similarly we can define the sizes of other sieves. So you can see here sieve larger than number 4 sieves are designated by the size of opening in the sieve. You can see here. So smallest sieves are numbered according to the number of openings per inch. So number 10 sieve means there are 10 openings in one linear inch dimension. So here are some sizes of the sieve as in mm. So for sieve number 4 it is 4.75 mm, and for number 6 sieve the size is 3.350 mm. So as I earlier explained that we can use different sieves for more explanation or more brief explanation of the sizes of the particles. So you can see the different sieve numbers with the sizes in mm in this table. Okay, now sieve analysis. So what are the types of sieve analysis? So there are basically 2 types of the sieve analysis. One is dry sieve analysis, and the second one is the wet sieve analysis. The dry sieve analysis is basically in the dry sieve analysis we oven dry the soil sample before performing the sieve analysis. Then we pulverize this soil sample to just break the clumps of the cohesive soil. So then we perform the sieve analysis, and in the wet sieve analysis we use water, and then we perform the test. So that is why it is called wet sieve analysis. Now what is the scope? So sieve analysis is used to classify coarse grained soil. So using the sieve analysis we determine the percentage sand, percentage gravel, and percentage fines. For the determination of size of fines, like fines are further categorized into two types. First one is clay and the second one is silt. We cannot determine the size of silt and clay using sieve sets. So we perform hydrometer analysis to determine the size of clay and silt. So that is why sieve analysis is only used to classify coarse grained soil. And grain sizes basically influences the filter design in dams, filter material, compaction, etc. So this is the scope and what is the equipment needed to perform this test. First one is sieve set that comprises of different sieves. You can use different sieves like number 4, number 10, number 16, 20, etc., etc. Then weighing balances. You can see here the sieve set. You can use more sieves in this sieve set. Then the balance to weigh the soil specimen. Then bowl and cleaning brush to clean the sieves. And then procedure, how we basically perform the sieve analysis test. The first step is to set the sieves in a sieve set so that the sieve with the larger size, i.e. sieve number 4 usually, on top, and then gradually reduce size below, like number 4 sieve on the top, then number 10, then number 16, and so on. In the next step, take own dried soil sample 300 to 500 gram for fine type of soil, and if your soil sample contains the particles which are having the size greater than 4.75 mm, usually the gravel particles, then you will use 1000 to 1500 gram soil sample. But but normally soil with the different particle sizes, we can use 300 to 500 gram soil sample. So this is basically the representative amount of soil sample required to perform this test. So again, the oven dried sample should be pulverized. Why we pulverize the soil sample? To break the clumps of the soil. Then pour entire sample in a sieve set. Okay. In the next step, place the sieve set in shaker and shake for about 5 to 10 minutes. So this is related to the shaker, but you can perform the sieve analysis manually as well. You can manually shake the sieve set for approximately 5 to 10 minutes, and then remove a nest of sieves and record mass of retained soil material carefully, and then compare the total mass with the mass of soil taken initially to perform test. So the meaning of this sentence is that let's say you took the soil sample of 500 grams and you perform the sieve analysis test. You pour the soil sample in the sieve set, then you manually shake this sieve set, and you weight the soil sample retained on each sieve, and then you added or you obtained the accumulative mass retained, and you found out that the accumulative mass is 490, 497 grams, etc. There is some loss of material of soil sample, so it is acceptable that there can be some loss of soil sample while the performance of the test. And then the question is how much soil sample loss is allowable. So for sieve analysis, the soil sample should not be lost more than 1%. If your loss of soil sample is more than 1%, then you have to repeat this test, and you have to perform the test carefully so that the loss of the soil sample should not be greater than 1%. Okay. Now you can see here this is the shaker, and here the sieve set. Then you just shake the soil sample for 5 to 10 minutes to obtain the soil sample retained on different sieves. Now, here comes the observation and calculations. So, before discussing the observation and calculation part, I have made already one video over the calculation part of the sieve analysis that is more brief. Let's see the same thing. I have already discussed in one of my video that how we can basically perform the calculations of sieve analysis. So here you can see this is one of the example we will discuss here. This is sieve number 4, 10, 20, 40, 60 and 200, and these are the sizes in millimeters against each sieve number. 4.75 to mm for number 10 and so on. Now you obtain soil retained on each sieve. For example, mass of soil retained on sieve number 4 is 25.87 gram, and on number 10 it is 56.3 gram and so on. In the next column you have to obtain accumulative retained mass. So to obtain the cumulative retained mass, you simply put this value here, then you will add up the previous value in the next value. Like you will add 25.87 into 56.3 and you will obtain 82.17. This is how you basically obtain the accumulative mass retained. Now for the next one you will add 82.17 into 133.42 grams and you will obtain 215.59. Then again you will add 215.59 into 166.7.85 into and you will obtain 383.4 and so on. Now you can see here the soil accumulative mass retained is 497.2 grams. It is possible that you might have taken the soil sample of 500 gram and after the performance of the test your accumulative soil mass retained is 497.2 grams, but you have to make sure that the loss of the soil sample is not more than 1%. So the next step is to obtain percentage mass retained. Now here one of the important point is you have to obtain the percentage. So to obtain the percentage, what you will do is you will divide 25.87 with this amount, not the original amount you took to perform the test. Like it is possible that you might have taken 500 gram soil sample, but to find out the percentage retained soil, what you will do is you will divide 25.87 with this 497.2 into 100 and you will obtain 5.2. Then again 82.17 divided by 497.2 into 100 and you will obtain 16.526 and so on. Now you will be able to complete this column. Now the last column is to find out the percentage passing. Look, now the mass retained on sieve number 4 is 5.203. Now how much the percentage of soil mass is passing through the sieve number 4? It is understood that you will obtain 100 minus 5.2031 and you will obtain 94.796. It means the 94.79% of the soil mass is passing from sieve number 4. Similarly, you will subtract 16.52 from 100 and you will obtain 83.4 and so on. Now we are done with the calculations. Now we have to find out the percentage sand, percentage gravel and percentage fines. Now let me redefine the definitions of gravel, sand and fines. The material that is retained on sieve number 4 is called gravel. So 5.203% material is retained on sieve number 4. So it means percentage gravels are 5.2%. 5.2%. 5.2%. Sorry, here 5.2%. If I correct it, it is 5.2%. Okay. Now, so percentage fines, the material that is passing from sieve number 200 is called fines. So percentage passing off from sieve number 200 is 0.98%. So it means fines are 0.98%, approximately 1%. Now the definition of sand is that material that is passing from sieve number 4 and that is retained on sieve number 200 is termed as percentage sand, or you simply subtract 100 minus 5.2 minus 0.98 and you will obtain the percentage sand, and that is percentage sand will be equals to 100 minus 5.2 plus 0.98 and you will obtain percentage sand, and it is approximately 94%. 94% is sand material. Now the soil is coarse grained soil. As you know that the material passing from sieve number 200 is less than 50%. So this is one of the objective of this test we have obtained through this calculation. So now you can watch this video. I have given the link here to understand more briefly that how we can perform this calculation. Now gradation curve. The next step is to draw the gradation curve from the sieve analysis test results. So here you can see what you will do is you will plot a graph of percentage passing and particle size in mm. The detailed procedure to draw this curve, I have explained this procedure in the video link given over here. You can check you can check from this video that how we can draw this curve. So now we will plot the graph between percentage passing and particle size in mm. This is a semi-log graph. So here you can see it is in logarithmic values. Now the next step is to find the coefficient of uniformity and coefficient of curvature of the curve. So the formula for coefficient of uniformity is d60 divided by d10. d60 is basically diameter of particles against 60% passing. So here you can see this is 60% passing and the diameter against 60% passing is, you can see here it is approximately 1 mm. Yes, 1 mm. And then d10, you can see here the particle diameter against 10% passing, 10% passing is you can obtain from here. Then this is how you find out coefficient of uniformity, and in the next step you have to find out coefficient of curvature. Coefficient of curvature, the formula is d30 square divided by d10 into d60. Now if you have to define whether the soil is well graded or poorly graded, so for well graded gravel the condition is coefficient of uniformity greater than 4 and Cc should be between 1 and 3, and for well graded sand Cu coefficient of uniformity should be greater than 6 and Cc should be between 1 and 3. If one of the condition is not satisfied, then the soil is termed as poorly graded. Okay. So here is the definition of coefficient of uniformity. It defines the uniformity in gradation curve. A large value of Cu indicates that D60 and D10 differ appreciably. You can see here if the D60 lies over here and D10 lies here, so this distance defines the uniformity basically. You can see here if D60, if Cu value is higher, it means the ratio between D60 and D10 is higher. So coefficient of curvature, it defines the curvature or concavity of curve between D60 and D10. Value of Cc greatly different from 1 indicates particles are missing between D60 and D10. So the value of Cc greatly different from 1 indicates particles are missing between D60 and D10. So value of D60, D10 are used for filter design in earthen dams or to surround the opening of pipe laid in ground for sub-drainage system. So this is the use of the diameter of particles basically. So now here are some of the definitions of the particle gradation curve. You can see well graded curve, gap graded curve and poorly graded curve. The curve which is more steeper is poorly graded representation of the soil sample. It means the poorly graded means the soil is containing the particle sizes of almost in the similar range, means the particles are of the similar sizes. That soil is called poorly graded. And the meaning of well graded is that soil is containing large amount of different size of particles. So this is termed as well graded. If some of the portion of the size of the particles is missing, then it is called gap graded curve. So you can see here this curve is termed as poorly graded because it is containing very less range of the particles. That is why it is termed as poorly graded. It is more flat, this green curve, so it is covering the large range of particles. That is why it is called well graded. And you can see here some of the portion is missing in this curve. That is why it is called gap graded curve. So here is some of the definitions. So now discussion. Sieve analysis does not describe particle shape, round, rectangular, etc. So this is one of the limitations you can see here, and it is very important to remember that sieve analysis does not describe particles shape. So it cannot tell us that whether the soil particles are having shape of round or rectangular whatsoever. So material loss after sieve shaking should not exceed 1% of the total mass, as I have already explained this. We must be careful regarding the performance of this test. Soil should be properly pulverized so as to break the clumps while not breaking the particles. So the meaning of this sentence is that if the soil is containing some fine content, when it will have some moisture content, it will form the clumps due to its plasticity. So it becomes necessary to oven dry the sample and then to pulverize the soil to convert the soil to its original size. But one should ensure that the soil original size should not be broken. So we have to pulverize very carefully to just bring the soil sample or soil particles in its original size. So if more than 10 to 12% passing from sieve number 200, then we perform hydrometer analysis to determine further the size of fines, like the size of clay and silt, which are subcategories of fines. So we perform hydrometer analysis for the determination of sizes of silt and clay, but the limitation is if the soil is containing 10 to 12% of fines, then we can perform hydrometer analysis. Otherwise, if the soil is containing 5% fines, then we cannot perform hydrometer analysis. If it is containing 8% fines, we cannot perform hydrometer analysis to determine the particle size of clay and percentage clay and percentage silt as well. So it can be performed on organic and inorganic soil. So the sieve analysis can be performed on organic and inorganic soil as well. So this is all about this lecture. I hope you like the video. If you like the video, don't forget to subscribe and share. Thank you, and Allah Hafiz.